All right, so we started our unit on matter, and I know it looks like, my goodness gracious, Mr. Bourne, you've already pulled the anchor chart from yesterday off the wall and started a new one. Absolutely, because we know most of these words, and I'm going to be honest with you, learning about solids, liquids, and gas is not a thing that I'm going to spend a week on. Like, you either have paid attention and you get it, the 3 states of matter, or like some people in the other room, I'm not too sure you've listened all year, because you don't even know that water is a liquid and that ice is a solid, and they were missing the questions at the end of this in the review. You'll see how easy they are. And like, we were all like, it was almost like, I really think somebody was doing it on purpose to be funny, because there's no way they were missing those questions. If they're missing those, I mean, absolutely easy questions, then we're not going to do so well on the quiz on Friday. Matter. We watched that video yesterday. Matter is a very important vocabulary word. It is anything that has mass and takes up space. I'm not going to take the time today to open up the whiteboard and type this in there. We did that yesterday. There's no one in here that wasn't here yesterday, correct? Josie, you weren't here yesterday? Okay, she says she's already got her notes. Matter is anything that has mass and takes up space. It's on your vocabulary sheet that you've had since last week, and it's on here as well. Moving on. Volume, very important word. Again, I'm not spending a tremendous amount of time on this. Why? Because you did this with Miss Comento. You went over volume a lot. That is the amount of space an object takes up, or for some of them, how much space is inside of an object. Because you can take an empty box and you can give me the volume, or you can just give me the total volume of a box, which is kind of the same thing, how much space it takes up. Shape is very easy. We didn't even write that down. I don't think that's on the vocabulary sheet this week. I don't see shape. Nope. And I don't think it's going to be on the quiz. If it is, it would be probably the outline of Bigfoot, and you would know what the answer is pretty quickly. Again, just for now, 3 states of matter, right? You'll get into some of this other stuff like plasmas when you get into chemistry, maybe. I don't even know if they get into it. I haven't looked at their study guides and stuff in middle and high school to see if you talk about plasmas. I'm certain if you're in college in chemistry, you would get into it. Solids. Who can tell me what you remember about solids? Yes, you can look at the board, you can look at your notes, you can look at the anchor chart, or you can just remember what you remember. Victoria. They have a definite shape. Take up a definite amount of space. What else do you remember about solids? Because that's not the only thing that I wrote yesterday. Evan. The molecules are very close together, minus water, but water's weird. It's weird for a good reason, right? Because if the molecules in water got super close together, it would be denser than water when it turned into ice, and it would sink, and then the fish would die because ponds and lakes would freeze from the bottom up. Because water expands when it freezes, the molecules are actually kind of further apart, which is very weird, but it makes it less dense so the ice forms on the top so the fish don't die in the winter. What else do you remember? Forgot what you were going to say, no stress. Ice is a good example of a solid. If we're talking about water, that's the only example of a solid if we're talking about water. Moving on. Liquids. What do you remember about liquids from yesterday? Yep. Liquids take the shape of their container, but they definitely take up a certain amount of space, right? There's only so much liquid that I can fit inside of Finley's water bottle. It takes up a very certain amount of space. If I need like more space, I would have to get a bigger container, right? Liquids take up a definite amount of space. Gas. What do you remember about gas? Chloe says no definite shape, which is true. Gas does not have a definite shape, and it does not take up a definite amount of space. You can condense gases inside of things to an extent where, I mean, there's a certain point where you've got the molecules about as close as you can get them, and you can let that expand and go out. And we talked about yesterday about how a lot of people have to put air in their tires this time of year because as it gets colder outside, the air inside of your tire is contracting because it's cold. That's what things do when they get cold, making it seem like you have less pressure. mean, you do have less pressure because the air's not pushing out as much, and you have to put more air in your tires this time of the year. Keep it on rolling. Here are some pictures. I drew something similar to these, right? If I'm looking at my anchor chart, yep, something very similar, just to kind of show what the molecules look like. Now, my solid that I drew was a little different than a solid of ice. I drew like a solid object where the molecules are super close together. Remember, water is very different. It expands when it freezes. Very unique element. We know that there's good reasons behind all that. We will come back and watch all this. Obviously, I can't show another person's YouTube video on my YouTube channel. It's copyright laws. We'll watch that when this video is over. And all those too as well. All right. This is a fantastic example. I would rather you have this page as far as like the molecules than that other page. That other page was really looking at molecules of water. This is just talking about solids, liquids, and gases. I like the fact that these molecules show that they're very spread apart in gas, close together and flowing over each other in liquids, and very close together here in a solid. I think that's a fantastic view of that. Now, changes in matter. Can matter change? Absolutely. We did this already when we did the triangle with all those crazy like arrows that go around about adding heat and losing heat. Remember that with heat exchange? We have to talk about it in heat exchange. We have to talk about it now. We're going to talk about it again when we get into chemical and physical changes. Solids. There's your solid, another good example. Liquids are here. And then gases. We've spent all this time reviewing solids, liquids, and gases. Yes, ma'am. The triangle was during heat exchange. Remember you had like it to go from a solid to a liquid was melting and you have to add heat, and to go from a liquid to solid. It's right there. That really weird anchor chart right there. Maybe you were out. You remember that? It's like a triangle, but then the circles on the outside of it. It's really weird looking. But we talked about the adding of heat and the losing of heat in order to change from those things. Now, we'll come back and watch Bill Nye in a minute as well. Melting point. I don't think that I need to spend a lot of time talking about melting point, but I'm going to. And in a little bit, Josie, you'll see, like when we're doing the games, you're going to be like, now I know what you're talking about, Mr. Bullens. Because it's very easy to say melting point is solid to a liquid, but when they say what is a melting point and they give you 4 choices, and they all seem similar, solid to liquid, liquid to gas, gas to liquid, you're like, wait a minute, time out. Oh, that's too much stuff at one time. Let me think about this for a second. But again, melting point. If you think about ice turning into water, not a problem. That is a solid turning into a liquid. If you look at the board, the only thing that I wrote on the board is solid to liquid. I'm going to put that here on our whiteboard. Maybe if it'll let me type today. There we go. For those of us that can't see all the way over there. Now listen, I'm not putting all of those words that you see up there. The exact temperature at which something turns from a solid to a liquid. Victoria, we're all smart. We all know that if I put an ice cube on your desk and a rock on your desk and we come back from lunch, we're not shocked that the ice cube is a puddle, but we don't expect the rock to be a puddle. It's not warm enough in my room. It will never be warm enough in Mr. Bullen's room to turn a rock into a puddle for certain. We wouldn't be shocked if the ice didn't melt in my room, right? I keep it pretty cool in here. Not today, it's warm, but typically. But yeah, I mean, when we're looking at this, melting point's pretty easy. Solid to liquid. That's it. So I know, Sydney, you were asking about that triangle. We're actually drawing the triangle without drawing the triangle. We're talking about all the movements from solid to liquids to gas. You'll see the triangle at the end of all these notes. So again, melting point. Is it possible for me to change liquid into a gas? Absolutely. That's called the boiling point, or evaporation, or vaporization. All of those words mean the same thing. Boiling point, if you look at my anchor chart over there, liquid to gas, and then I put evaporation into parentheses because it does mean the same thing. So again, this thing's going to do the same thing it did to me yesterday, isn't it? I need to contact them about that because that's annoying. I don't want that. That's what I want. I don't understand why it does that every time. All right, boiling point. Liquid to gas. Evaporation. Everybody good on boiling point? It's on your screen. It's on the anchor chart. Hopefully it's in your notes. Everybody good? All right. All right, not only do we have the boiling point, we can actually go from a liquid to a solid, which is the freezing point. The freezing point of something. When I pull up the whiteboard, you can see I have that here, freezing point, liquid to solid. It's very easy for me, Chloe, in my head, say water turning into ice is freezing. That's the way that I have to do it. When you see all of these things put together, sometimes you just have to change it into water, and it makes a lot more sense, and it's easy to think about it. So when I say liquid to gas, it's like, give me a minute. But if I say water to water vapor, oh, that's evaporation. That's boiling, not a problem. It's just so much faster in my head because I'm able to think of it a lot easier. But again, if we're looking at the freezing point, that's the point at which something turns from a liquid into a solid. A liquid into a solid. I'll get that little dot out of the way. It's driving me crazy. There we go. Everybody good with that? All right. I'll come back to it if you're not in the back. Condensation. Mr. Bowens, that's the same slide, you cheater. Yes, I am. I copied the exact same slide from heat exchange and plopped it right into here. Sure did. Same picture too, right? Except I moved it from this side to this side. I was trying to be sneaky, but not whatever. Why would I redo it if the slide was correct the first time? Right? Condensation. Yes, it's cloud formation, but in this instance, we're just looking at states of matter. We're talking when a gas turns back into a liquid. When a gas turns back into a liquid, which we were able to see. Who watched with their parents or watched the dojo video? Not many of us. That's fine. We'll watch it now. I went outside because I heard that there was a dense fog warning. Fog is a low-lying stratus cloud, and I wanted to go outside and see what it would be like to be in a cloud. It looks something like this. These are water droplets.
If you can go outside tonight, do it, take a flashlight. See these tiny little water droplets just floating, rising.
Can you see the convection? I mean, some of it's just wind, but if you can definitely see the convection over the flashlight. But that's when it's moving side to side, that's just the wind. That's literally the moment that condensation has happened, when you see that. Condensation is when that gas is turned back into little tiny drops of water. Condensation. There it is, gas to liquid. Now that, when you say it really quickly like that, it's like, wait a minute, just hold on a second. I have to stop and think about that. Yes, the water evaporated. It went up into the atmosphere. It's a vapor. It's a gas. And it turns back into teeny tiny little drops, which is how we get our cloud formation. Everybody got condensation? I mean, you should already have it in your notes, but if you're putting in there a second time, Ava J, that's cool. I don't mind. I mean, it's going to be on the test. It's going to be on the quiz. It's going to be on the benchmark. Having condensation written down more than one time is not going to be a bad thing whatsoever. Everybody good? All right. I'm going to pop back up. I'll leave the whiteboard frozen at the end of this. I've only got a minute left up here to record this video, though. So there's condensation. Here is that picture that we have on the board. Ours is a little different than this, right? Solids, liquids, and gas. But I said to go from a liquid to a solid, I had to take away heat. And to go from a solid to a liquid, I had to add heat. That's what we did during heat exchange. So this states of matter triangle is not going to go away at all. You'll even notice that I started talking about down here sublimation and desublimation. These are very interesting changes because they both skip the liquid phase. It is possible to see something go from a solid straight into a gas and not become a liquid. That would be very weird to see, right? Like if the ice cube is there and it like just kind of disappears in front of you, that happens at the tops of huge mountains. And then the opposite happens when frost forms on your car like it did this morning. The gas turns straight into a solid. Like and subscribe, click the notification button, blah, blah, blah.